free body diagram. Do we want to leave it on the angle?
What? Sorry, repeat that?
So the first question is asking us to draw a free body diagram. Do we want to leave it on the angle that it's at? Do you guys see that?
Yeah,
Yes.
so...
Yeah, it's...
Does it give us the angle? The angle is... It doesn't give us the angle.
Well, it says 3, 4, 5 triangle. So it's going to be 3.
Oh, I'm dumb. Thank you.
You're good.
Okay. Well, I suppose we should start by drawing a free body diagram.
Yeah.
Yeah.
Right,
So there's force of gravity going down, static friction. So like by down I mean like straight down -y. There's static friction going towards the wall the string is attached to. Normal force perpendicular to the surface.
I think, yeah, so it says slippery ramp, so we don't need to worry about friction. I don't think we're going to need to worry about normal force.
I mean, it doesn't hurt to add it, even if it, like,
right. Yeah. But we do have the gravity going down, and the spring pushing, I guess, down the slope, which with a force of well, I suppose it'd be KS times the, well, if you want to break it down into X and Y components, but we can do that in a sec. But it would be, what, 120, or the force of the spring would be 120, because that's the stiffness, times the distance,
displacement.
The stretching, which would be 2 minus 1. Because it is at 2 meters times 0, and the relaxed length is 1. So the force of the spring would be 120 going in, well, down the ramp direction, which we can find out the X and Y components in a sec.
Wait, the force of the spring is going down?
Well, down the ramp.
It's going,
well,
is it compressed? It's stretched, right? So it goes up?
Right. So it'll be in the negative direction then. So I guess...
Are we ignoring normal force and friction?
Friction we are ignoring because it says slippery ramp, implying no friction, and normal force I think we should ignore just because I don't see how it would be significant.
Should we just for the free body diagram, just draw a line, maybe?
Yeah, I mean, I'm just including it. I don't think
we can.
Force.
Okay, we can.
But which direction is the spring force going?
So the spring, the spring would be pulling upwards. Sorry, up the ramp,
because it's stretched.
Yeah, or pushing down at a negative force, but it's whatever.
Pushing. Okay. Never mind.
So.
I think that's it, right?
Oh wait, starting velocity is -1. What the heck?
Oh, I just wrote all of those down. Like, I didn't actually label those. Like, I just wrote them at the top of my paper. I don't think we need to label it.
Yeah.
Oh, okay. Sorry, missed this. The X and Y graph is tilted to align with the slope of the...
Oh.
So gravity is the only thing that we actually need to split into X and Y components. Gravity would be... Right, okay. Which would mean the... Okay. So the block's velocity is -1 on the x direction, which would push it, so it's currently being pushed away from the, I guess, wall at the top, but the spring force is pulling backwards. All right.
Wait, so do you still have gravity pointing just directly down?
Yeah, gravity would be still pointing downwards, but what we consider negative y is no longer straight down.
Okay.
You have to tilt your, yeah.
I'm gonna have to remake this in Paint.
Okay, so just to make sure I have everything right, you have F of gravity pointing straight down, and then you have F normal pointing up in the positive y direction,
Mm-hmm.
and then you have F spring pointing in the positive x direction.
And then
Negative
also,
X, or positive, sorry.
yeah, so the force of spring is pointing in positive x, and in velocity 0 is in the negative x direction.
Okay.
And that's -1 meters per second in the x direction. And yeah. So
Awesome.
other relevant information, t equals 0.0, or dt is 0.02 and t is 0.04 for the future.
Yeah. So the next part is what principles, concepts will you need to solve this problem? What is the question? You're going to need the momentum and position update.
Okay, we have to type this.
So, and that's just the momentum principle too, so you can type that if you want.
Yeah, I'm just doing momentum and position update principles.
Awesome. What assumptions, approximations do you need to make?
Friction is negligible.
Better. Yeah.
Negligible. What else did I say? Normal force is ignored. Unless, if you guys disagree with me on anything, just let me know.
So
yeah.
friction is ignored.
Mm-hmm.
I don't think we have to mention normal is ignored because in the lecture they say gravity cancels out normal. Anyway, so
Except now they're not canceling because normal force isn't in the same, or isn't in the opposite direction of gravity anymore.
Oh
yeah,
no,
that's why the spring is, or that's why the object is going down.
But that's why it's going downwards. But the normal force is counteracting the -y on gravity. So the only force that we need to pay attention to is -x on gravity, because yes, yeah, that is correct.
Yeah, you're right.
Yeah. All right. Just when I said that, it sounded weird because gravity going in the x direction. Right. So, okay. So normal force isn't ignored; it counteracts the y component of gravity. But friction is negligible. Air resistance is negligible. Anything else?
I think that's good.
Yeah, that's
Neato.
Okay.
and never mind.
Huh?
It said gravity constant is 10 meters per second, like, but that doesn't matter.
Yeah.
I was gonna say like it's usually 9.8, but that's probably not an assumption.
Mm-hmm. So the system would be the box, and and the surroundings would be the spring, earth, and
The surface.
And the ramp.
I suppose, yeah, the ramp. Flying through this.
Okay, solve the problem. I hate this part.
Okay, so we need to oh gosh. Okay, so start off by setting the lost for words here. Setting the momentum or velocity, really. Actually, we
start with solving F net.
yep. I was getting to that. Yeah, right. F net that would be the force of gravity and the
Force of the spring.
force of the spring. There we go. Both of those are going to be in the x direction. So gravity, let's work out this triangle. That would be what is that? 60
10.
degrees on top and 30 on the bottom. That's not how that works.
It's gonna be cosine of 30, I think.
Oh god. Okay. No, this isn't one of those triangles, I don't think. It would be the angle theta, and with the bottom left would be the, I guess, the tangent inverse of 3/4.
Because you have
Which would be
cosine 30 is adjacent over hypotenuse, and then you have the adjacent is going to be in the x direction. Right, so doesn't that give you gravity in the x direction? Cosine 30
Oh.
times mass times gravity, so 10 times 10 times cosine. Does that make sense?
Yeah.
I don't think the triangle is 30 degrees, 30, 60, 90. That triangle, a 30, 60, 90 triangle would be 1 square root of 3, 2. And this is 3, 4, 5. It's a different ratio. To solve for the angles, we need to do good old-fashioned trigonometry. Luckily, I just did the math, and theta in the bottom left corner, oof, if I did this right, I might have done this wrong.
Like that?
Yeah, 36.87. 36.87 degrees-ish, which would mean the other one, I suppose instead of arctangent, we could have.
Okay.
How did you figure out the sides of the smaller triangle
These,
with for the gravity to find the components of? Because I know you draw out the components, but how did you go about like finding the actual components?
they should be similar.
Like,
What are you asking exactly?
okay, so we know that the biggest triangle is the 3, 4, 5 triangle, but when we draw out the force of gravity vector and then we do the components, the x and y, you said those weren't 3, 4. That's not a 3, 4, 5 triangle. You said it was like a similar triangle.
Oh, well, if two triangles are geometrically similar, then their angles would be similar as well. No, or maybe that's congruent, but I don't know. But they.
Oh no, yeah, okay.
Yeah.
Yeah, okay.
It matters like the small triangle is going to be, because you're just going to do mass times gravity times the cosine of 36.87, right?
36.87. That's the lower left angle. The top right angle would be what, like 53.13.
Yeah,
50.13
like
degrees.
you just need the angle, right?
Sorry, what was your question?
So when you're like finding the force of gravity, don't you just need the angle, because it gives you mass and gravity. So then you just multiply by the cosine of 36.87, right?
Yes.
Okay.
I'm gonna double check that with. I'm just gonna double check that because I never trust myself to get this right intuitively.
Wait, so what did you guys get for the magnitude of x of gravity? For the x component of gravity?
I'm putting it in right now. I got 79.99989.
So we're gonna do 80.
I got 67.55. Where did I get that?
Did you do 10 times 10 times cosine 36.87?
10
Yeah,
times 10.
I might be on
Oh.
radians. I'm on radians.
Oh, yeah. Gotta make sure you check.
Okay, that's, yeah, I got the same as you. Basically 80 units.
Okay, yeah, I'm just putting 80.
Or do you guys want to do you guys want to computate, like, you want to calculate some parts, or do you want to get the exact answer then? Like, you want, like, in the middle of our steps, you want to calculate, or do you want to, like, keep exact answers until the end? Do you know what I mean?
I don't think it matters, but I think it's good to at least check and make sure we're close.
Okay.
Now, are we completely certain that we did the triangle math right? Because the axes are tilted, so so it makes it confusing. This would be 53, meaning 30.
Wait, just so I'm on the same track, what do we have so far? What do we know yet?
So
As of right now, he's still checking this, but I have that the force of gravity is the x component 0, the y component's 80, or negative 80, I should say, and the z component 0.
The x component is what?
0. The only component that's there is the y, and it's negative 80. For gravity.
there should be
Didn't we say-
y should be 0.
Yeah, there should
Yeah,
be
why-
something
That's-
at least. And
yeah,
I
that's-
thought I got, isn't it negative 80 in the x
Yeah.
component?
We like switched. I'm sorry, that's my bad. Because we switched the what's it called? We switched our
Axes.
and
Yeah.
Okay, so it would be in the that one would be in the x direction. So x would be negative 80, right?
Yeah.
And then y would be
Why we don't care about? Because it's cancelled out by normal force.
and
Yeah,
then
so
we don't have a
it's
right?
10 times the cosine of 36.87. Is that what we agreed?
Mm-hmm.
Right.
Are we sure it's cosine then? If it's in the y direction.
No, it should be in the x direction, and I'm fairly certain, unless if I did my math correctly, it should be, well, negative 10. So 10's in the hypotenuse, x is in the, well, x direction. So the cosine of 36 would be, no, wait, cosine of 50 is 3. Shoot, I'm pretty sure it's the cosine of 53.
Yeah, I
For
think
what?
with a different orientation, I think it would be 53. because it would be in the x direction, so you'd be doing, if you're doing opposite over hypotenuse is
53,
the
36,
opposite.
50. Yep, 53. 53. And it would be the adjacent over hypotenuse.
Wait, hold
But
on. So
if we're looking for it in the x direction.
Yeah, so,
yeah, so why is it not 36.87? Isn't that adjacent to our?
all right, so I'm gonna draw some pictures and then I'm gonna send them in the Discord, and I'll show you kind of what I was thinking.
Eric, you're doing this electronically, right?
Oh well, I'm currently doing it on pencil paper, but I can't do it electronically. I do have it
Okay.
pulled up.
I
to
was
do
thinking
that.
maybe you could like Discord stream or something. and we
Discord
could just,
stream. Right. Okay. Yeah, I'll
Yeah.
set that up quickly. Screen, and we'll do. Screen 1. All right. Cool. Yeah.
Okay.
So that will actually make it easier. And just
Yes.
gonna double check. We're still. Yeah, it should
Okay,
still be going.
actually, yeah, I think you're right with that one. I think it is cosine 50.
All right, pulling up my
So
favorite
whatever.
paint. So we have the. Just gonna draw. Oopsies. We'll just draw like a box. Ooh, this is.
There's a box shape in the shapes. That's
You
fine.
know-
You already.
Well, it's like that. But you know what?
Oh,
I-
never mind.
Yeah. So we're gonna box, and our axes would be, well, actually the slope would be like this, and the triangle would end up being like this, which means the, just so we're familiar with the angles, this is 36-ish. 36 degrees. This would be 53 degrees. The top angle. Is everyone watching?
Yeah.
I am, yeah.
Cool. We'll just put the spring right here. Now, the triangle, so gravity is pulling down. Gravity is pulling down this way.
Yeah.
We'll draw arrows, which means, can I? Okay, apparently I can't choose anything in between this. Which means this angle right here is also 53 degrees. And
Oh.
if you take, we'll go like gray. If you try and orient it with the x-axis, which this would be the, sorry, this would be the y-axis, and this would be the x-axis. That would mean the angle right here would be 36 degrees. We change that to red. And if that's 36 degrees, that would mean, we'll do black. That would mean this triangle, which is parallel with the ramp, this angle right here would be 53 degrees.
Okay, that makes sense.
And so if we want to find this x component with this being gravity, we would need to do the cosine of 53 times g, which would be 10, to find x.
Also,
And then
let's
x
play
would be in
with
the
mass.
negative direction.
We do mass and gravity. M and G.
Yeah. But, well,
Okay.
yeah.
I see what you mean. It's fine. So is it 53 exactly, or
No, it's
some decimal?
53.13 is what we'll estimate.
Okay.
Right, so
What do you guys get?
so far for the FNet we have, well, negative 10 times cosine of 53.13. And then we also need to subtract the, no, we would add the spring force, which is
Oh, it's not.
120 or
There's also another 10 you multiply by.
y.
So it's negative 10
Mass.
times 10 times cosine
10
of 50
times.
degrees.
Yes. Okay. So I'm just gonna do 100. Thank you for that.
So it's 60, or negative 60, I should say.
Yeah.
And then for the spring force, it's pretty easy because it's just 2 minus 1 meters times the spring constant, which is 120.
So it's 120.
And that's
Right?
just an extra. Yeah, or it's negative 120, I should say. Actually,
No.
can someone
No, it's in the
explain
positive
that?
x direction.
Yeah. I was about to say, because isn't it, if the spring is being pulled, it's going to be positive, but if the spring is being compressed, it's going to be negative, right? Or does it just depend on the direction it's going?
I think it depends on the direction, right?
Well, stretch would be how far it's stretches from the base of the spring to the from the object to the base of the string or spring. So if it's being stretched, then the net force of the spring on the object would be towards this. I don't know. I'm just going to do this intuitively. It's towards the spring, which would be in the positive x direction. That's
Okay.
Yeah, that's just how I'm going to do it. Also, so the thing that I'm caught up on is, are we absolutely sure that we can just add gravity to the force of the spring? Because gravity has a mass attached to it and springs do not. So I'm going to
Well, we're okay.
the heck?
Because you're worried about the block itself. You're not worried about. So the block is gonna have the force of the spring plus the force of gravity. So you take both those into account for the FNet.
The spring is exerting 120 newtons on the block.
Yeah.
So
and are we saying that gravity is expressed in newtons?
Yeah.
Right. Okay.
Okay, and then, so after does everyone have FNet? Did we all get 60 in the X component for FNet?
Mm-hmm.
and then 0, 0, 0, 0, 0,
Yep.
0, 0.
Sorry, so you said that's 60?
Yeah.
Yeah.
Because it's negative 60 plus 120.
Are we heavily rounding, or is it?
No, it wasn't bad. It was, because 10 times 10 cosine 50, 3.13
Right,
is
okay. Wow, that's
60.000.
all right. Well, that's fair.
Yeah.
So
You
60.
just take what you have on your saved calculator and the final computations. We'll just put those numbers together. Like it's saved on your calculator, right? Like you do. Never mind.
No, I
It's
know.
okay.
I know what you're saying. So. Okay.
Okay, so now we have FNet. You can find.
Right, and that will change after each iteration. And oh, gee, there's 2 iterations. Okay, but should get easier from here, because the only thing we need to recalculate is the spring force, and that can all be automated if we wanted to. But
Okay, you guys wanna we update momentum now, right?
yeah, so momentum is I'll let
P
you guys.
future equals P now plus FNet times delta T. So what's our current momentum?
I think you'd have to divide everything by mass to like use the velocity version, kind of, because it gives you an initial
yeah, it gives it
velocity.
velocity. So So our initial momentum should be -10.
Yeah,
Or initial, yeah.
correct.
Yeah.
Mass times
Wait, our
velocity.
initial momentum is 10 in the x direction?
-10.
Yeah. Sorry. Minus 10 in the
Wait.
x direction.
So it's going up. No, it's going down on the ramp.
Correct.
Yeah.
When it starts.
Wait, do we have to do for the initial momentum? Do we have to go and just put it in the x direction, or do we just do the whole thing?
The do the whole thing, but it's gonna be 0 in every other direction.
Yeah.
So it's just gonna be -10, 0, 0.
Correct.
Yeah.
Plus
Okay.
what?
Plus 60, 0, 0.
60, 0, 0 times
Whatever that-
0.02. And then, so that's just momentum. And then we plug that bad boy into the position. And it is currently,
Are you guys writing the formulas out before you plug it in, or do you just
nah, I mean,
write it down?
I just write it down.
Sure.
Yeah, because momentum's just past momentum plus force, and position is just past position plus momentum, and both of those are times dt.
Okay, so what do you guys get for your momentum at 0.2 at t equals 0.2?
Wait, for your
Point
momentum?
02. By the way, it's 0.02.
Oh, 0.0. Oh, okay.
Mhm.
Thank you.
You're welcome.
So I got -8.800.
Oh. Okay.
What? 0.02 is 1/50, or wait, no. Yeah, 1/50.
Yeah,
60
50.
over 50. Wait. 60 over 50
It's
is
1.2.
yeah, so 8.8.
Yeah, -8.8.
Right. Oh, I thought you just said 8. My bad.
Oh, you're good.
Okay, I got something similar. I plugged in the old 60 newtons from like the exact answer, like the decimal.
Right. What'd you get?
-8.799999.
Right. We're gonna round that bad boy to 8.8.
Yeah.
Okay.
8.8 kilograms meters per second.
Oh shoot! Should we be putting units on these?
Yeah.
Meters, seconds. Neat.
Okay, now we update position. And then that's
Yeah. Also, what's the difference? There's been like different like equations for it, because one of them you add, so it's R initial plus like V average T plus F net delta T squared.
I think they're all
Divided
saying
by
the
M?
same thing.
They're all the same?
I think so.
Okay.
Mhm.
Okay, so our initial
And what's our
position.
initial position?
Our initial position is -200, and that is because the spring's length is 2 meters and the spring is only on the x-axis. So it's
But the spring at rest is 1 meter.
but the spring isn't at rest at t equals 0. The spring at t equals 0 is 2 meters.
No, so you want to make initial our initial position at origin? What is our origin?
Our origin is 0, 0, which is the base of the spring.
Okay. Makes sense.
Mm-hmm.
Wait, so then the initial position is 0, 0, 0, or is it -2?
-2.
Oh, okay.
0, 0.
Mhm.
And then is it V average or V initial times delta T?
The average. So that's future momentum, or momentum at 0.02 over m.
Okay. So we have to use our like old or the thing that we just solved for.
Yeah, the thing that we just solved for divided by the mass, which is 10.
Awesome.
So 1 over 10 times minus 8.8. 0, 0.
So did we already calculate our final position for the first time step already? Or are we still calculating that?
We're doing that right now.
Okay, I'll wait.
I have it all written down. I don't want to put it in a calculator. I suppose I could.
I got. Or let me know when you guys are ready.
Okay, I got an answer.
I got negative 2.0176.
Same.
I got negative 2.015 too. So I don't know if you're using the exact numbers, but
I use the exact numbers, but don't worry, it's almost the same
it's
thing.
so close. Yeah.
Well, we're just going to 2.01.
2.01, yeah.
Okay.
Negative. Make sure it's negative. Yeah.
Oh yeah.
All right.
So the
Wait,
block
what?
is still on
Does
its
that-
way down, and it's slowing down.
Okay. Right.
Sense that it's slowing down because it has the spring.
Yeah.
Yeah, and it's about to be pulled up. Looks like. Now we need to update momentum again.
And FNet.
Oh yeah, and FNet.
Estimate first, right? Because we have.
Mm-hmm.
Yeah. So the distance, the string is being pulled. The string is being stretched now as 1.0176. If you want the exact.
So it starts at 2. So wait.
So initially it was 1, but then we moved. When we were at negative 200, or the relaxed length of the string is 1, so it was 1 times 120. Now we moved 0.0176, so it's 1.1076 times 120, or negative.
Minus 1,
wait.
so 1.0176.
Negative, right? Because.
Yeah, sorry, it's not negative.
Alright. So for the new estimate, did you guys get 61.824?
60. 1 sec. I didn't get that. I got 122.112.
Yeah, but you have to go and add negative 60 to that for gravity.
Oh yeah. Sorry. I thought you were talking about the force of the string.
Oh, no, you're good.
So you got what? 62?
I got about 62, yeah, it was 61.8.
Okay.
I mean, I got 62.112, but that's pretty
Yeah.
close.
I got that too.
Are you guys using the exact numbers? Because I'm not.
I am.
Yeah, I'm using the exact.
Okay.
It's fine.
Okay, yeah. So mine are probably going to be a little bit off. I've been rounding most of them.
And then now we update momentum again.
Yeah.
Have you got an answer yet?
I'm still working. Give me a second.
Okay. Take your time.
So, what did you get?
Negative 7.56.
Okay, I got negative 7.557. Same thing.
Okay. Same thing here. Yeah.
Awesome.
Eric, are you good? You
Uh,
got the same thing?
yeah, sorry, I'm just trying to do two things at once. I'm trying
Don't worry
to
about
make a work checking thing. So that way we
Don't
could,
worry about it.
yeah, just in case we can, so we can verify. What do we get for the FNet? I missed that.
62.112.
62.112.
And then, of course, 0.
Yeah. 0, 0, 0, 0. Cool. And then, right. For the momentum, we made sure to use the minus 8.8 for our past momentum.
Yes.
Yep.
Cool. Just a sanity check. Here. And just 0.02. Cool. Yeah, and then we're probably ready to do the position update now, which is minus 2.01 for the new position.
Yep, don't do average velocity, so you gotta take those divided by 2. Oh wait, no, you just do the momentum. So we can assume
FNet.
that.
Oh yeah, momentum divided by mass.
Mm-hmm.
Do we have to claim that as one of our assumptions?
That what?
That average velocity equals momentum divided by mass?
Well, one of the first
I don't
equations
think
they
so.
gave us was momentum divided by mass times dt. So I'm gonna say probably
Were
not.
they okay? Were those approximately, or were those like actually equal?
I'm pretty sure they were equal. Well, I mean, obviously, like everything here is approximate until we start using calculus. Well, and
Yeah.
even then, it's approximate. Nothing here is going to be 100% exact, but it's going to be super close. So,
Okay, so
some,
we don't need to claim that then.
yeah, unless we wanted to claim like every step we're doing was an approximation. At least that's how I look at it. The professors might view it differently.
Okay, yeah, I think we're good then.
This is the fastest I've gone through like a recitation, so I'm
Yeah, I
very
know.
thankful for this.
Yeah, right.
Yeah. Okay.
Yeah, it's a lot better when multiple people are.
Yeah. Currently we
together.
are 45 minutes in. Okay.
45.
Yep. So it's fast, but not that fast.
Yeah.
Plus equals.
Okay, I got a final answer.
Sorry, I'm looking for the old exact numbers. I lost a 2.0176. Like the exact number for that one, so just do 2.0176. And then did you guys get anything for final position?
Yeah, I got negative 2.03.
Yes.
Okay, I agree.
Awesome.
Awesome. Is
And
that the
that's-
last one?
So you got 2.1013?
Negative
Negative.
2.03.
Well, look at that. I did too.
Awesome.
Just in time.
Yay.
Yay! Okay, and that was with a loop, so I'm gonna hope that, so okay, so negative 2.01364 if you guys want to add a couple more digits. 0, 0. Wow, that's awesome.
Okay. I don't know what you guys talked about in like your last, in the part where it's like construct an argument to explain and justify your solution. Like, I don't know what to say for those.
Oh.
Yeah,
okay,
I don't either.
And like, I think, because I was talking to the TA last week, and he was like, and because I was confused about like, are there other ways to solve this problem? I didn't ask him about it, but he was like, oh, like, eventually you guys won't have to do this because you'll just be coding it.
Oh.
So like, basically what you're doing, yeah.
Right.
So I was like, in the answer for are there other ways to solve this problem, can you just say you can code it so that it does the while loop, so it just like goes through it?
Oh, maybe. That kind of makes sense. But I don't think, because we were never told that we were going to code it.
Well, I have a while loop if we wanted to if we wanted to just paste that into the, I mean, you guys can
Yeah,
see.
I don't,
That
there's
would
no
be-
other
yeah.
ways to solve this problem, I don't think.
Sorry, 22.
Yeah, I can't think of anything else.
Maybe solve for velocity and then actually solve for the average velocity and did like,
But
But I don't
technically
know.
we did solve for average velocity through
yeah,
momentum divided by mass.
so, I don't know. I
Let's
kind of just said, oh, you could possibly do, like, in my last answers, I was pretty wishy-washy about it, and I was just like, oh, you could try and do this, but you could code it.
well, don't think it means like electronic or like on paper.
But I don't really know what to write for that.
Yeah,
You
yeah,
could just
that's-
put that you verified it in a while loop, and that you, I don't know. You can just. I don't think they're really gonna go too much into that.
Yeah. And then in your argument, incorporate why the chosen principles, concepts, and assumptions and approximations are relevant to your proposed solution. Just because we didn't have to take into account like friction and the resistance and stuff, so it didn't like it was relevant because didn't it say it's like on a slippery surface or something?
Okay. What? You wanna just? Okay, that makes sense. But like, I feel like we're just like, what's the difference between this and then the beginning when we explain how we're gonna do our thing?
Okay, well, I have to go because I have something at 8:30. But what I'm gonna do, since I'm not gonna be here for the second half, I will just post stuff in the discussion because I feel like that's at least for this problem too. I will like the free body diagram and stuff.
Actually, would we just want to do another round tomorrow, and then maybe our other group member will show up tomorrow, and then we can just push both of them, like separately?
Yeah.
Right, I can stitch it together as well.
Yeah, would we want to do that, or do you want to keep going? I don't particularly.
Well, I mean, if it's different if like one person's gone versus like if two are gone. I mean, I think we can just do it tomorrow. I think
We can do it
Yeah.
tomorrow.
What time though?
probably. Oh shoot, I have to. Yeah, I could do 7 still.
I think 7 works for me too. Do we want to all try and work on this problem by ourselves, and then just talk about the solution?
Yeah.
Sure.
Yes, I think that would be faster. No offense.
Yeah, and-
No offense.
No, it's fine. But if then that way it's quicker and it's easier to just verify. And then if someone gets it wrong, then we can go through it step by step.
Yeah.
So, and then
What
if
is
someone
this? This is
Go ahead.
also position momentum update, right?
I think so, yeah.
Okay, good.
I think the hardest part is going to be setting it up.
Yeah.
But we can honestly just ask each other questions in the Discord chat if we have any issues setting it up. And if you don't get to it by tomorrow night, we can just go through it again. Because I don't know if I'm going to have time to do it tomorrow.
Okay.
But
So, quick question: can we do any earlier time than 7 or no? Like 6, we can't do 6.
I have
Like,
a thing that is probably. I can't do 6.
Okay.
And honestly, 7
I'm-
might be pushing it. I might get back at 7:30, but I will try my
I
best to
see
get
it.
back at 7.
like in the morning or anything?
Oh, in the
Let me check
morning?
my schedule. Yeah, I can do basically any time tomorrow, I think.
I'm an online student, so I have all the time.
Well, can anyone else do morning?
I can do morning.
Has anyone? So Elizabeth, have you looked at problem 2 yet?
I have not. I did not have time to do that today, but I can pull it up real quick.
Okay, that's fine. I also did not have time to do it.
Well, yeah. All right. Who have I not met here yet? I haven't met one of you.
Chris, defer.
Chris? Okay.
Yeah.
Nice to meet you, Chris. I'm Elizabeth.
Nice to meet you, Elizabeth.
Have you gone over the first recitation problem with anyone yet?
Yeah, I figured it out for the most part.
Okay. Perfect.
Right, so that just leaves number 2. And I looked at it a little bit, and from the 5 minutes that I worked on it, it honestly seems pretty straightforward. It's just a position update thing, but our net force is using the gravitational equation rather than
Well,
anything else.
I haven't looked at it in a long time. Hold on. Like, as in, what do you mean by gravitational equation?
Like negative g times mass 1 times mass 2 divided by the magnitude of r
okay.
squared times the unit vector r.
Okay.
And I'm gonna
Okay.
see if I can do this in real time. Like, upload pictures.
So this time I'm guessing we can go a little bit quicker.
Yes,
Since we like have the whole idea down.
And I feel like I'm already 90% of the way done. At least conceptually.
Okay. I mean, that's a lot of it.
I think, so that's force. Then. Right, we're just gonna. So, okay, so are you guys looking at the problem now?
Yep.
So it gives us two masses, planet and star, with the position vectors of each of them, and then an initial velocity. So step one would be, I guess draw a free body diagram, but that's simple. It should be.
So it's just a planet orbiting a star, and then only force should be a gravitational attraction.
Yes, I'm gonna try and upload pictures as so I'm streaming like last time, but not stream, but on Discord.
Yeah.
And I'll try and upload pictures as they.
Press enter. Yeah.
Right. Okay, so this is the. Oh, do we need labels? I'm just gonna.
Labels.
Label all. Never mind. So this is
I think
it.
yours is fine.
Yeah. So sun, planet. We have the gravity on both sides, and then an initial velocity on the planet.
Yeah.
Okay, I think your diagram is good.
For the principles and concepts, we'll need the gravitational equation.
Gravitational force.
You're recording, right, Eric?
Yeah.
Okay.
Oh, Chris, how this is working is I'm recording audio and I guess technically video because I didn't want to figure that out, and I'll just upload it. We recorded one last night and we're gonna record one today. I'll stitch them together and upload it.
Sounds good to me.
Mm-hmm.
And then we need position and momentum update.
Correct.
And hopefully that's it.
Mm-hmm.
Assumption, since we're in space, there is no resistance of any kind.
Right.
Yep.
No friction or air resistance. I'm also going to say that the sun's velocity is 0 because it doesn't actually tell us. Right, so I'm going to, yeah. Velocity of the sun is 0. And
I think that's it.
ignoring relativity. Or do we not even need to worry about that
Ignoring-
normally?
Well, we're not having any significant interactions,
Right.
so don't think so.
Yeah, sure. Okay. System, planet, surroundings, sun. That was easy.
Yep.
And then solve the problem. Do you think that we could just upload like code for the solve the problem section?
We can ask. That would be actually cooler idea
Is
because
it-
we do momentum and position updates so much. Like,
Right. I mean, it'd be really
So
nice to
much
just
better.
have to like.
Yeah, I feel like
Yeah.
future in the class we'll be able to do that, but I don't know that we can do that at this point.
Right. So
Also,
I'll
you keep saying the sun, but are we just calling the sun like the star sun?
Oh,
The sun?
yeah,
sorry.
the
Sorry.
sun is a star.
Star. It's my bad.
Same
I-
thing.
Okay. Just want to make sure we don't
Star. Mm-hmm.
change
Sun
anything.
slash star. Okay, so FNet shouldn't change between
Yeah.
time
FNet.
intervals, right?
Correct.
Yeah, no, it's
FNet equals negative G
what is
times.
G equal? Is that like
That's
It's a constant.
G is
It's just a constant number.
6.67 times 10 to the minus 11. And I can throw that in the Discord if you want.
I just have it up on the slides. It should-
Right. Oh, right. Well, then I will delete this from the Discord.
I mean, no need to delete it. That's fine.
Mass 1 is
Oh, I have to pull up the formula.
times 3 times 10 to the 24. Magnitude of
Wait, so is this is just coulombs, right? So it's just 1/4 pi epsilon naught, and then times.
Wait,
Q1
whoa,
times
what?
Q2. Is it
What do
that
you
one?
think?
Sorry, no. This I don't think
Because
so.
that's the one that says.
That's
um,
electric force.
Oh, that's electric. Sorry, I'm at the wrong point.
Yeah, go back a
In my
page.
notes.
Mm-hmm.
Yeah.
This should be negative G times mass 1 times mass 2 times the unit vector of R, all divided by magnitude of R squared.
Squared. Yeah.
Yep, I should close all my notes. And what is R? R is 2 times 10 to the 12th. Or whatever, minus 2, doesn't matter.
2 times 10 to the 12th?
Maybe minus 2. 2 times 10 to the 12th, and then 0.
Hold on, we just updated it once, right? No, 2 months later. Okay.
Mm-hmm.
Wait, can you read that equation again? Are you using
Minus G times mass 1 times mass 2 times the unit vector of R divided by the magnitude of R squared.
I'll just take a picture and post it in.
Right,
Okay.
yeah,
No, I got
yeah.
that, yeah. Sorry. Yeah.
Yeah, I haven't looked at it.
I just wanted to check and make sure you had that right. Okay.
Wait, is it the unit vector of R? No, R is the distance between the two, right?
R is the distance between the two, correct?
Yeah.
And the unit vector be minus 0.7. Sorry, yeah, no, I was right. 0.7, and then 0.
Oh wait, but wouldn't we have to take into account the direction for the next timestamp?
That's why you'd have the unit vector,
Mm-hmm.
right?
But the
Yeah.
direction changes though as
Yeah, so we do it twice. We'll update it again.
okay.
We'll recalculate net force. Minus. You guys should tell me what you get for the signs, because for some reason, no matter how hard I tried, I always flipped the signs. So,
For which portion?
for the net force, once you calculate it.
I mean, I very well could have messed up, but I got negative 3.5126 times 10 to the 23rd x component, positive 3.5126 times 10 to the 32nd for the y component, and then 0 for the z.
What did everyone else get?
Still on it, sorry.
You're good.
Are we looking?
Let me see.
Are we looking for the distance, like
30,
relative,
24.
like from the star? The distance of like. Okay, never mind. Hold on.
Wait, I think I'm having the same question. Is
Okay.
it distance from planet to star? I think I'm gonna need to draw this.
Yeah,
Yeah, from-
or star
from-
to.
It's from planet to star.
So
Or
it's
wait,
from
no, we're
planet-
sorry.
No,
You
it's from
said it's
star to
planet minus star,
Planet
planet
minus
minus
star.
because it's from the star to the
Star
planet.
to the planet.
Oh, okay.
Sorry.
Yeah, I'm checking Audrey's work too
Okay.
as we go along this.
Oh, did she paste hers in the Discord?
She put it.
Oh,
I think she put it in the Discord.
Yeah, she did.
So I have hers pulled up. So I've been cross-checking my stuff with hers.
Minus what? I don't think she did negative. Yeah, I don't think she did negative g. Even though it says negative g, her unit vector is the same as the force vector. It's the same direction.
Okay. Just something we gotta tell her. That's a quick fix. Probably.
Yeah, it's just flipping the signs, which the numbers look right though.
Yeah, I haven't gotten
Mhm.
to like that portion of it yet, but yeah, I
Uh,
noticed that it looked like she dropped a negative.
Chris, read me your numbers again, or actually read me your equation.
I might have had it backwards now that I think about it, because when I look back at it, I think I did star to planet instead of planet to star. So
Yeah, so planet should be, if you're going mass by mass 1 and mass 2, on bottom it should be R2 minus R1, and mass 2 should be planet.
because that's the one that's moving versus mass.
Yes.
Are you?
Eric, what did you get for your unit vector?
My unit vector was minus 0.7.70.
Okay, good. It felt wrong for some reason.
Yeah, it's weird because, I mean, they're supposed to add to 1, but it's the squares that add to 1, and 7 squared is about 50.
Oh, wait, I did it correctly.
What were your numbers, though? Your numbers...
Multiply times the magnitude?
No, divided by the magnitude, and then the magnitude squared. Or divided by... Yeah, the magnitude squared. You know, I can just... Very simple for me to... I'm going to take a picture of the equation and just post it in the Discord, so that way in the future we can all have it very quickly.
Okay, also another thing to point out
Mhm.
to Audrey is she forgot to multiply by. I don't know where she got this answer.
What? Minus
Oh,
what?
she forgot to divide by 10 to the 12th. She forgot to include that in her unit vector because she like pulled out 10 to the 12th.
Yeah, I
But then
wasn't
when she
sure
was
about that. Yeah, her unit vector was odd.
yeah, so that's another thing we're gonna have to
Yeah.
tell her about.
But the numbers are right. It's just the powers of 10.
It's just the powers, yeah. That's the only issue that I've seen with her work so far, and the drop negative.
Mm-hmm.
Um,
All right, so the equation.
Sorry, I'm still typing this
that's
into
me.
my calculator.
You're fine. You're fine. Don't worry about it.
This is a very big equation.
That was from yesterday.
Yep.
Okay, so for my force of gravity, basically F net,
Uh huh.
I got negative 3.502 times 10 to the 32.
Sorry, negative for your F net.
3.5 for the x component.
Now that's interesting because you and Chris both got that, but Audrey
you
and I
upload
both
your,
got.
Thing to the Discord.
I uploaded the equation of gravitational force to the Discord.
Okay.
Oh,
Uh,
I didn't square the denominator.
Right, and Chris, I think you made the same. I don't think you squared the denominator.
For which part?
For calculating the net force.
Eric, what did you
yeah,
get?
I got 1.24 times 10 to the 20th as my numbers.
Yeah, that's what I got.
And that's what Audrey got too. Chris and you both got 3.5, which is if you don't square the denominator, I think.
Yeah, I think that's what it was. Let's see. Sorry, what did you get?
Oh,
One
I
more
see
time?
what you mean. Yeah.
What did I get?
I got 1.23.
Yeah. I rounded. It's 1.23, 1.238.
Yeah.
Yeah. Okay.
And then the x component's positive, the y component's negative, and then the z component's 0. Are we all?
I thought the x component is negative.
I got positive for the x component.
Because it's negative in the unit vector, but then you're multiplying by the negative g.
Oh yeah,
Mhm.
I forgot that negative too. Okay,
So-
are we all good on the force of gravity?
Yeah, so net force
Answer?
at this time, or we're just to confirm, is positive 1.24 times 10 to the 20th. For the y component, it's minus 1.24 times 10 to the 20th. C is 0.
Yep.
Fantabulous. All right. Now we need to what? Momentum update, and then the others update, position update. So we should, since we're given a velocity, let's just turn the momentum update into the velocity update. So we'll do, just because it'll make it easier. Velocity is the current velocity, which is 0.3 times 10 to the 4, 1.5 times 10 to the 4, 0, plus our F net.
Sorry, what did you say?
I'm
1.5.
So I'm just reading off of the worksheet
Oh, okay.
for velocity, the starting
Sorry,
velocity.
I was scared for a second.
No, you're fine. You're fine.
So we're just gonna do fnet divided by m
Right. Yeah. 1 over.
for the.
Yeah. 1 over mass. Oops. Almost forgot about that.
And don't multiply by delta t.
Mm-hmm.
And we also divide by delta t by mass, right?
Well, they're
That's the
multiplied
whole
together.
thing?
Multiplication is commutative. This should be fnet times delta t divided by mass. Or
Yeah.
1 over mass times fnet times dt. One over, what is the mass? Mass is planet, so 3 times 10 to the 24. Which would be less than time.
Which mass are we dividing by?
The planet.
So the system
planet.
is
Planet mass.
So
Mhm.
it's the planet mass.
Yeah,
Yeah.
Okay, awesome. Thank you.
you're welcome. V equals we'll do F times dt times over mass of the planet. Print V. Oops.
What did you guys get for your x component?
3.2 times 10 to the 5th, or 332,000, or no, 321,880.
Okay. Smaller number than that. I got wait, you got 3,108?
I got 3,107, so.
Yeah, I got 3,107 too.
I'm in the
329.
300,000s. Okay.
Did you divide by doof?
Mass?
Yeah. What mass did
Yeah.
you divide by? Actually, what
3 times 10 to the 24th.
odd. Read me. So your time step? What did you multiply by?
2.6 times 10 to the 6th.
Weird.
I think you might have multiplied or something instead of added like the
Ooh,
94th.
that could be it.
Oh, yep.
Yeah.
Thank you. I have a habit of pressing multiply by. I'm still getting something big.
All good.
Here we go. That's why. R. Here we go. All right. We'll just pull that to the side for later.
Okay, so you guys got what? 3,107?
Yeah.
Okay. I got the same.
F net R unit vector. Okay. Neat.
Okay, so for the Y component, I got 15,107.
15,107.
I got
I got
14.
14.
Yeah.
Yeah, 14,892. Maybe that's close enough. It's probably rounding. I would check that though, because it might not be rounding.
Did you guys got negative? No, you guys got positive, right?
Correct. Positive on velocity.
14,892.
Yeah.
So in
107.
your F gravity, is your Y component negative?
No.
Yeah, so it needs to be negative.
Oh yeah, it is.
Yeah. Okay.
It's negative.
What's the initial position?
I might have mistyped something.
Yeah, I would recheck that.
Looking through it.
For the position update, for average velocity, are we just putting in like the final velocity that we just solved for?
Yeah.
Yeah.
Okay.
What is the update when you use velocity to update position?
It's position update is always old position plus whatever your like velocity times dt, or momentum over mass times dt.
I always convert them into momentum, so.
Mm-hmm. And then velocity, to get from the momentum equation to the velocity equation and back, you momentum, the entire thing divided by mass, gives you velocity equation, and velocity equation, the entire thing multiplied by mass, gives you the momentum. I lost the word for that.
Oh, good.
Yeah.
I get it.
Mm-hmm.
I'm not sure. I'm looking through. I don't know where we're wrong.
Read me the numbers.
Okay, so I did it in separate steps because I wasn't gonna select. I could find the problem. So I did 1.238 times 10 to the 20 divided by 3 times 10 to the 24th
0.3. Wait, divided by... ooh, my bad, never mind.
for the mass.
That's my bad.
Wait,
Yeah.
did you start with a negative 1.238 times 10 to the 20?
No, no, he said positive. It should be positive.
Wait, are you in the X or the Y component right now?
He's in the
The
X.
Y.
Oh, you're in the Y?
Oh,
Yeah.
that's what it is. Yeah. Okay.
Yeah, that's the negative I was talking about.
Sorry, I keep messing up in this. Like.
No, you're good. You're good.
No, you're good. Don't worry about it.
Ooh. How many zeros is this? I don't want to convert this to scientific notation. 1, 2, 3, 4, 5, 6, 7, 8, 12.
Question, for our position update, are we going to do the 1/2 acceleration times delta t squared? Do we want to do that part too?
No.
No?
No.
Okay. That's good, because I didn't want to do that part. So, you only do that when you need it to be more specific, right? That just adds another layer.
No, I think it's just
No.
the same thing.
Or
Just a different way of doing it.
yeah, we don't have acceleration though. Well, that's using the
Well,
derivative.
Acceleration is basically.
I mean,
F net divided by mass is acceleration.
Right.
Yeah, so
So-
it's like, it's just the same thing.
Wait, so are we doing the part where you have F net divided by mass?
No.
No, that's why we calculated final velocity.
We already took the mass out of FNet.
But position update formula, it's initial position
Mhm.
plus average velocity,
Yeah.
delta t,
Yeah.
and then sometimes it's plus 1/2 F net over m times delta t squared, that portion.
Well, that's it. I think that's just another way of
Well,
rewriting it. Should be the
you're
same.
pulling from the kinematic equations, right?
Yeah, that one is from the kinematic equations. That's the one we used it last night during problem 1. We used it. But-
We didn't do minus 1/2 AT or whatever. Plus
No.
one.
Oh yeah,
Yes.
well that was just another way of doing that one. I think it's the one. Was it the one that said use momentum principle?
That one only works if you have a constant
Ah, there we go. Thank you.
force or momentum.
Oh, okay. Wait, last night was it constant?
Yes.
Was
No.
Wait, no.
No.
You had to update. That's why.
We didn't use it last night.
Yeah, no, it was a constant.
Last night we used our final equals our initial plus 1 over mass time. Wait, no, not 1 over mass. The heck? Oh yeah, no, 1 over mass times momentum times dt. I didn't write dt down.
Yeah. But
I
then
think I
we
calculated
also
it wrong.
added F net over m delta t squared.
I did
Maybe
not.
you didn't. It just. Oh, okay. Well, I don't think it matters because when I was on
F
the
over m would convert it into its momentum. Like that's what you do to get the force.
Okay, so what did you get for just the 1/2 acceleration times the dt
No, I
squared?
was talking on the office hours today. He said it's just if you're asked to be more specific. So I don't think it really matters. I can go and look at what my changes were, but I'm pretty sure they were really small.
Yeah, I would wager that if they're you probably only use that if they're not really small. But heck, I don't know.
Did you guys get the new position?
Almost. What did you get for your x component?
3.0080 times 10 to the 12.
Yeah.
Same thing. Okay. And for my y direction, I got 4.038 times 10 to the 12.
Yep.
Yeah.
And then we do it all again. F net equals probably.
Wait, can someone read that part off again? Was it? I got 3 times 10 to the 12.
Well, you're gonna want to be specific with that because we started with 3 times 10 to the 12. Do 3.01 if you're gonna
01.
round. Mm-hmm.
No, it's 3.008.
Yeah, which rounded is 3.01.
Yeah, I see.
Uh-huh.
Yeah. I was just checking to make sure I got a similar answer.
So it's planet minus star or star minus planet? Sorry.
Planet minus star.
Planet minus star. Okay. Wait, planet?
What'd you guys get for
The y component is 4.04 times 10 to the 12th, rounded, of course.
I think I missed something here.
I got 4.03.
Yeah, 38.
Okay.
38721.
0.04.
Correct.
Okay. Times 10. Okay. Thank you.
You're welcome.
Wait, do we have to go update F of G
Wait, so
again?
why is it?
Sorry, one
Update
question.
what?
Elizabeth,
Do we
what
have
would
to go? Do we have to go update force of gravity again?
Yeah, because
update?
it's moved.
Yeah. Mm-hmm.
Awesome.
You have to
Okay, just checking.
recalculate.
Wait, but why are we doing planet minus star again?
We're doing planet minus star because we want to go from the star to the planet.
But isn't it the force the star is exerting on the
Mhm.
planet?
Correct. And so the star would be 1, mass 1, because it's exerting on the planet. Planet, because it's being exerted on, would be mass 2. And the equation is
okay.
R2 minus R1.
Yeah, just think of it like it's the system. So it's gonna be the system minus the surroundings.
Yeah, that's good. That's a good
Okay.
way of abstracting
Yeah,
that.
yeah.
Okay, so for your guys's R planet minus R star, did you get negative 1.99 times 10 to the 12?
Oh,
2.0
shoot.
Huh?
Yeah.
Yeah?
I
Okay.
think, Eric, are you disagreeing?
Oh, no, I said, oh, shoot, because I just did it in a... I didn't
Oh,
I didn't
okay.
write it down. I just did it in a program.
2.04 times 10 to the 12 from the 0. What do you guys got?
Yeah.
For the final FNet, 1.204 times.
No,
or
for
what?
No,
for
just for the position
R.
function.
Just for the position. Okay.
Yep.
Yeah. Has anyone
Yes.
calculated definite?
Yeah.
For the x component, I got 3.5 times 10 to the 20.
You should square the bottom.
Oh, thank you.
You're welcome.
3.43 times 10 to the 30.
Oh no, I did. I think.
You
Yeah, I
did?
did. Yeah, that's weird. Wait, Elizabeth, what do you get?
I got 3.43 times 10 to the 32nd.
Are we sure? Because the
No, I got different from her too.
so the FNet should not change all that much from the previous FNet. So if we're getting like double or triple what we got previously, something went wrong.
Yeah, that's what I'm thinking.
Yeah, because what I got for the FNet was 1.205 times 10 to the 20th compared to 1.24 from previous.
That's a lot more plausible.
Mm-hmm. Are you guys
Yeah,
sure you both squared the bottom? Because when we didn't square the bottom, we got around the 3.5 range.
Yeah, I think I probably forgot to square that. Let me try again.
I'm gonna. What was your unit vector, Eric?
The unit vector should be minus 0.698 and 0.715.
I got something different. Okay.
Really?
I got that, Eric.
You got what I got?
Yeah.
Neato.
So what was 0.69?
0.698.
So then my magnitude was probably wrong. So what's your like distance? The vector.
Let me find that for you. After I.
What did you get for the x value for the FNet?
For FNet 1.204. Here, I'm just gonna throw this in the Discord.
Oh, I have a no. I know what I did wrong.
Wait, times 10 to the 24th.
Times 10 to the 20th. Wait, for what?
Okay.
10 to the 24th would be the mass. 20th would be the FNet.
When you calculate, how many decimal points do you go to?
It varies, whatever I'm feeling, but
Because my answer is like slightly different. Like,
when I do my calculations, there's no rounding.
okay,
Um,
probably why it's slightly different because I do round.
when I write down, there's some rounding. I usually write down what, like 2 to 4, or 0 to 4, 1 to 4. I don't know. Usually never more than 4.
Yeah, I actually wrote down my my x component for my magnitude for some reason.
Oh, I think I see my mistake.
And what did you get for your y component of the FNet?
I pasted everything in the Discord. So for the y component of FNet for at month 2 should be minus 1.233.
Check mine, make sure. What did you get for the magnitude of
The magnitude.
that you multiplied times the r unit vector?
I will tell you that in just a second. Magnitude. The magnitude should be like 2.85 times 10 to the 6, 7, 8, 9, 10, 11, 12. Wait. I didn't square it though. Are you talking magnitude squared or just the magnitude?
Like what you would multiply times the r unit vector. What I mean is the M1 times M2 over the R value.
M1 times M2 over without the unit. Oh, without the unit vector. Right. Give me 1 second.
Okay, I got the right Fnet this time.
Me too.
Print. The minus 1.7 times 10 to the 20th. Chris?
Okay.
That's with G in it as well. That's mass 1 times mass 2 divided by the magnitude squared times negative G. All of that is... Oh, and that's negative G as well, so... Yeah.
Okay. I think I realized my issue was just I had the wrong value. I must have miscalculated.
Okay.
Magnitudes.
3.16. 3.16. Okay, cool.
Has anyone gotten their X component for velocity yet?
Yes. I got...
Go ahead.
No, you.
I got 3002.94.
3,211?
No.
Sorry, you said what just read me your numbers. You kind of cut out a little bit.
Just 3002.
3,002.
Yeah.
Huh. Interesting. What'd you get for the Y component?
I haven't gotten the Y component yet.
3,002. That seems like that's close enough that it seems like it could be a rounding thing, but at the same time, that's a little off from what I got.
We've done a bunch of computations now, so it might be off slightly.
Oh, if you rounded every step, yeah.
Yeah, I've been rounding everything.
Oh, okay. Right. I've been rounding nothing, so that would make sense as to why we're so different.
Yeah, and then for the Y component, I got 14,785.68.
14,785?
Yes.
Oh, yeah, okay. Weird how you're 6% different from mine, but only 0.2 from whatever. It doesn't matter.
I mean, I can plug it in again and see if maybe I just wrote something out wrong. Like in my calculator?
Yeah, I would...
Try it out.
Yeah, because
what did you guys get again?
For the Y component, 14785. And then
for the X?
Well, I got 3211, but she got 3002. So
I got 3211.
You got 3211? Okay, interesting.
Yeah.
Yeah, I still got 3002.94.
Okay, weird. Maybe it is just truly a rounding thing.
And then what was your Y component again?
14,785.68.
I got 0.82.
About the same.
Uh-huh.
I got 0.6.
All
Wait,
right.
what did you guys get for your X?
0.4.
Yeah, what did you guys get for the X?
3,211.
Huh.
Eric, what did you get?
Same.
Okay. What did you put in for your initial velocity?
Initial velocity, like at the beginning?
Yeah.
Oh, wait. Do you,
Or
so,
like your
3107.
yeah, 3107.3. Oh,
okay, so
that
I
might
have that
be,
too.
oh, you do? Okay, weird.
Yeah, and then for your X component of F net, did you have negative 1.204 times 10 to the 20th?
1.205, but that shouldn't make a difference.
That shouldn't. And what about for your mass? It's just 3 times 10 to the 24, which is the same for all of us.
Yeah, and then that,
And then 2.6 times 10 to the 6th is our step, right?
right.
So I have no clue.
What the heck? 3.107, what was the decimal you put in? 3.107. What was
0.29.
0.29, okay.
That shouldn't have made a difference, like a
No.
200
No.
point difference.
Yeah, that's weird. This is gonna sound dumb, but try it on a different calculator.
Yeah, I feel like it's a calculator difference.
But I have no clue what it could be because it's one step. But even still, I think. Go on.
Are the values that you sent in the Discord like your final values?
Yes.
You got,
Mhm.
alright, mine match up with yours. So.
Neat. To the end?
Yeah.
Nice.
Oh, like all the way to the end. Okay.
Right, yeah. Chris, what major are you?
Biology.
Oh, nice.
It's a bit weird that I'm taking an engineering physics class.
I mean, whatever floats your boat, man.
But I mean, it counts for the credit, and I've heard like good things about the engineering physics versus the biology.
Right. I don't think you were. I don't think you were listening hard enough last semester. What a. At least my impression of it, it was just a huge mess when they switched to online.
It seems better this year, at least. And then the issue. See, it's weird, but I hate biology, even though it's my major. So.
What?
Yeah. No.
All right.
biology
You're gonna
sucks.
need to elaborate.
So, like, my least favorite classes I've ever taken at Purdue have been, like, all of the biology ones. So, like, having the choice between taking, like, physics where I have to do biology or just regular physics, I definitely decided that regular physics was more.
Huh.
preferred.
What are you gonna do, like, throughout the rest of college? Because obviously you're gonna take a lot more biology classes as a
Well, I
biology
mean-
major.
I can't.
What's your plan?
I'm already a junior, so
Oh,
I'm
okay.
getting a minor in chemistry.
Uh-huh.
So I'm going to do grad school for chemistry instead. Which
Oh, okay. Neat. Is it too late to go to chem?
I would have to stay, like, an extra semester, and I'd figure... it's not
Okay.
worth it.
All right. That's fair.
Are you online, Chris?
I mean, I'm at Purdue, but I have one in-person class, and it's a lab.
I see.
Pretty chill.
Yeah, I'm all the way in California. Online.
Dang.
I don't know if I'm missing out though as a freshman.
Yeah.
Other years maybe, but this year maybe not.
Because everyone tells me it's like it's not even worth it because like they can't do much, but like I feel like they're all lying.
No, they're not.
I mean, like yeah, but like you get to see people though, right?
That is true.
Like you can still talk to
Occasionally.
them.
Okay, I keep getting crazy answers now that I'm using a different calculator.
I would.
Are you putting parentheses around your scientific notation?
I'm doing like each thing like I'm doing it all separately. So it shouldn't, I've done it both ways. Maybe I'll try doing it all in one.
Because if you don't put parentheses around like your scientific notations, it like messes it up for some reason.
Yeah, I haven't been using the scientific, like, I've just been doing like each one and then like multiplying it. So that should
Yeah, even in those, I think if you don't put a parentheses, there's gonna be like slight problems.
Are all of you guys freshmen this year?
No, I'm not.
Which one is that, Eric?
Yeah. Everyone else is though.
Yeah.
It's funny because for one of my classes, I have to take anatomy, right? And the teacher retired like before this year started for anatomy 304, so I have to take the anatomy that they take for like nursing majors.
Oh. Okay. Branching out.
Yeah, and everybody in that class is a freshman.
Ooh. Or no offense to the freshmen.
So I had the lab, and the TA was like trying to help me. I was like, "Hey, like, I've done this before. This is my first time."
Yeah, that's always funny.
Okay, I'm just gonna like write it's probably a rounding error. And then
You
just
can,
move on.
if you want, you can ignore the fact that you're getting the weird answer and write down 3211.
By the way, the question asks for velocity and position. So when you write down your final answer, it's going to be velocity and position.
What is the vector force? Sorry, using a time set, find the new velocity and position. What is the vector force exerted on the planet by the star, and what is the vector force exerted on the star by the planet? So,
oh, never mind.
So it's asking for the vector forces, but you're right, it does say find the velocity and position.
Well, we already found the velocity, right? Because we're when we do like the position update, we're using that velocity, right?
Yeah.
And
then I think we need to calculate gravitational force one last time.
One last time?
Because it says what is the force exerted on the planet at this time? 2 months later.
Wouldn't at that time be like what we previously calculated? Like,
I think that was 1 month. That was month 1.
Yeah, we technically did 0 and 1. So at month 2, yeah, he's right. Technically, it would be yeah, I guess technically at month 2 would be, yeah. Yep. Although they could have just worded it weirdly. But I'm just going to dump a ton of stuff into the answer box and hope that they, whatever.
One of them.
So I wanted to make sure, so for the recitations now, since we're doing this, do we still have to post a discussion and stuff on
that? No. Instead what you post is a statement that you're going to copy paste from the announcements page that says basically like, I agree to the answer and participated in the discussion. And that's all you guys have to worry about. I'm going to upload the video.
And then we still have to submit the our own individual one too, right?
Yeah, and the solution. Which
can we all agree on this answer? Like, can I submit this? Is this ready to be submitted? Like, we can all agree on this answer, right?
Sorry, what was your answer?
Or well, like our final position. I checked with yours.
Oh, if you checked with mine.
And then Chris got the same thing.
Yeah.
I'm working on it. Did you post your answer in the Discord chat?
I still have to calculate the gravity.
Yeah, the gravitational force, if you guys are lazy, which I am.
Thank you.
Don't need to worry about it.
last week when we did the lab for this class, I submitted it in the wrong recitation, or the wrong like lab area.
Oh shoot, that
So
sucks.
I was like going over. I was like, what? Where is it? It was in my Bio 395 class.
That sucks. Oh what? Wow. Oh,
Are those
by the
10
way-
to the 12th in your position? Sorry.
In my position, yeah, it's 10 to the 12th.
Okay, awesome, thank you.
Okay, so by the way, the force that I pasted in the whatever, that's the force of the star on the planet. For the planet on the star, you need to take the same thing and invert it.
Invert it?
Well, negate it, so equal and opposite.
Sorry, I don't know what you just said.
Take the flip the minus signs for the force of the planet on the star.
Oh, I see.
Yeah, because it wants both.
Yeah. Should we also put our velocity in there? Velocity and position and enter, or just the force of gravity?
The velocity at month 2. You know, okay, so if we were to put velocity at month 2, we would need to recalculate it.
Solve that.
Yeah, technically, I
Just
think.
solve that.
No, velocity wouldn't. Because if you did the next velocity, you would have to use time, which would be another like month, basically. So the
Right.
velocity-
Okay.
Wait, that's at
okay.
month 2 though, like we just did that.
Okay.
Yeah.
Okay.
So we don't have to do it again.
Okay.
Because that would be month 3, right?
Yeah. I'm hoping if we're like 1 off, they'll like look at our work and be like, all right, they just overcalculated by 1. But I'm not too confident in that. But it should be right then.
How are you doing the force, finding the forces of the star on the planet and the planet on the star?
So,
The vector force?
that would be your FNet. So
That's what we calculated earlier.
Didn't we
For this
calculate that?
that would
Not
be
for month 2.
month 2. We decided was you would have to go 1 more to use the new position.
Oh, I didn't show work for that.
Yeah, but
Do I? I don't know.
I'm not. If they notice it and call us out, then
I lose 2 points.
oh, by the way, for answer 1, we need both momentum and position. For problem 1.
Oh, yeah. Isn't that what we did?
Oh, I just wrote
I
down
didn't.
position. But we solved them both, but I wrote down just position.
Okay.
And just to confirm, for momentum, we're doing minus 7.55700.
Yep. Or I got 558, the same thing.
Yeah.
Wait, momentum of what?
Problem 1.
For the final momentum?
Mm-hmm.
I got negative 7.56.
Yeah. Okay.
Same thing.
Okay, is that what you got? Okay.
Mm-hmm. And for our justify answers things, are there any other ways to solve these problems?
The I can think of would be like if we said, oh, you could have added the 1/2 FNet over mass times L 50 squared to get like more specific, but
You
that
also
would be like extra.
you also could have converted velocity into momentum.
Yeah.
Right. And then after we get that, the justify part done, I think we honestly should just be done.
Yeah, it's nuts right now. Sorry.
What were our assumptions again?
There's no kind of resistance.
And I said velocity of the sun was 0, but we don't. I guess we
It's
don't
star.
need star. Sorry, but I guess we're not actually using that in any way. So
We could say there's like no other things in space. Like there's no other.
oh yeah, no other no other objects. Okay.
Wouldn't the star be the surroundings?
Yes.
Okay, just making sure, because whichever person did it before, they wrote the planet as the surroundings and the stars.
Surroundings would be star. Oh yeah. What's her name? Audrey. Yeah. Okay. We should.
Should we post our individual answers on the discussion board also?
Audrey can take a look at them. I think that might be a good idea.
Mm-hmm.
Wait, so this can be done through momentum update and kinematics, right?
Yes, but here we go. Alright. Well, I'm gonna stop recording now. Save my hard drive. I think we got it though.